Hey, greetings everybody. This is Mr. Beckstrom again, and today we're going to be talking about Chapter 5, Section 2, Trigonometric Ratios. So buckle in and let's go. So in this section, we're going to be talking about our trigonomic functions, sine, cosine, and tangent, and what they mean. So when dealing with right triangles, remember, it's a triangle that contains a 90-degree angle. We often use these sines, cosines, and tangents because they're really useful. If we have a triangle and we know the angles of that triangle, then we know the ratio of its sides because it's going to be the same no matter how large or small you make that triangle. So for example, if we have a triangle with a 90-degree angle, a 60-degree angle, and a 30-degree angle, the hypotenuse is always going to be twice as long as our shortest leg. So if our hypotenuse was 100 meters long, our shortest leg would be 50 meters long. And if our hypotenuse was 1,000 meters long, our shortest leg would be 500 meters long. So we have that nice relationship that we can look at when we're dealing with 30, 60, 90-degree triangles. Even with the longer of the two legs, we still have a relationship between each of the sides and that specific leg. And we're going to be doing some examples with those in just a moment. So when we talk about the trig function, sine, cosine, and tangent, we're really talking about the ratio of those sides for a specific angle. Alright, so here is all the formulas. Let me see if I can move that a little bit here. And you see this is the sine of A. So the sine means the opposite over the hypotenuse. So if this is our angle A, the opposite would be the lowercase a. The hypotenuse is always going to be our longest side, which is the lowercase c. The sine of B will be opposite lowercase b over hypotenuse, which is lowercase c. And the cosine is going to be adjacent side over the hypotenuse. So if we're talking about A, the adjacent side is the leg that is touching that angle. So the adjacent side would be the lowercase b. The hypotenuse is always going to be that lowercase c. So the cosine of A would be little b over little c. The cosine of B is going to be the adjacent, which is little a, over the hypotenuse, which is little c. And we also have the relationship with the tangent, which is the opposite side over the adjacent side. So if we're talking about B, that would be opposite, little b, over adjacent, little a. If we're talking about A, we're talking about opposite, little a, over adjacent, little b. So when we're talking about the hypotenuse, the opposite, and the adjacent, let's kind of understand a couple of things here. The hypotenuse is always going to be this longest side, but the adjacent is going to be the leg that's touching the angle that we're talking about. And remember, we're never using our right degree, our right angle, as with our trig functions. We're always using the other two angles, which have to be strictly smaller than 90 degrees. So if I'm talking about A, my adjacent will always be the one touching it that's not the hypotenuse. And the same thing with the angle B. It's going to be the side that's touching it, which is not the hypotenuse. And then the opposite is the side that doesn't touch that angle at all. So the opposite of A would be little a, and the opposite of big B would be little b. There's maybe something that you learned in high school. It's called Chief SOHCAHTOA. It's spelled SOHCAHTOA, and it just stands for sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So it might be something that you want to look up and try to memorize or try to learn it that way. I know it helped me when I was in school. So let's talk about finding values of trigonometric functions. So this we're going to need a calculator for. You either really want a scientific or a graphing calculator, and you want to make sure that it's in the degrees mode. So you want to hit the mode key if it has one and change it to degrees if it's not already on there. And then you simply just put in your trig function and the angle, and you press enter. So for example, if I wanted to know the cosine of 45 degrees, make sure that I'm in degrees here, hit equal, and I get 0.707. That's all you really have to do for that. All right, let's talk about the inverse of a trigonometric function. So with the regular trigonometric function, so when we just learned, we're given an angle and we're trying to find the corresponding value or ratio. With the inverse, we're given that value or ratio and we're trying to find that angle. So if they were to ask you something like the sine of what angle, or the sine of big A is equal to 0.5, they're saying what measure angle for the opposite over the hypotenuse gives you a ratio of 1/2 or 0.5. And for that, we're going to use the inverse function. It should look like the sine function with a little -1 in the upper right hand corner. For a lot of calculators, you hit the second and then the sine button, and we'll be doing an example with that as well. Just take a look at this really quick. Let's say I want to find the inverse sine of 0.5. Make sure that I'm in degrees. I go up here and I'm just going to do inverse sine 0.5, and it spits out 30 degrees. That means that it's a 30-degree angle that gives me a ratio for the opposite side over the hypotenuse side of 1/2. All right, let's move on here. Let's look at example 1. What is the sine of 34.2 degrees? So try it out, see what you come up with, and then come back. And all we're going to do is just go to our calculator, make sure that we're in degrees. We're going to go to sine of 34.2 equals, and we get this. So I'm going to round this to the second decimal place. It just depends on how they ask you, but this time I'll just do it to the second decimal place. We're going to get 0.56, and that's it. So I just go over here and I write 0.56. So if they ask you the sine, cosine, or tangent of some angle, just type in the angle, make sure you're in the correct mode, hit enter, and you should get the ratio. And just a second here. Sorry about that, I had a quick phone call. Alright, so let's look at example 2. Find the sine, cosine, and tangent of this angle T. So try it out, use your formula, see what you get. Alright, so looking at that triangle there, what do we know? Well, we know that the sine is the opposite side over the hypotenuse. The cosine is the adjacent side over the hypotenuse. And the tangent is the opposite side over the adjacent. So all you do is just plug in those values and divide them in your calculator. So 33 divided by 65 is approximately 0.51 rounded to the second decimal place. And that's the same thing for all three of those. So not too bad. You're just asking for the ratio of the sides that correspond to that angle. Alright, so try a couple more of those in the book and see how you do and on the homework. And lastly, let's do an inverse function problem. If the cosine of some angle B is equal to 0.589, what is the measure of angle B? Well, this is one of these inverse relationships we're talking about. Instead of giving us the angle and making us find the ratio, they're giving us the ratio and asking us to find the angle. So in those cases, when we're trying to find that angle, we need to use the inverse function. So I'm going to go to my calculator and I'm going to do the inverse cosine of, see what that was, 0.589, and it spits out about 53.91. So that would be the angle that gives me that ratio of the adjacent side over the hypotenuse. And that's it. Just put that number in. Oops, I didn't change it here. That should be 53.91, so 53.91, and that's it. And if you have any questions, make sure to send me an email, give me a call, and we'll see you next time. Thank you.